Hi, my name is Xian, and in this video, I will present the PSM2 on my work. So the title is the automated passenger counters for using deep learning algorithm with vertically installed camera. And my supervisor for this project is Dr. Pan Yuyong. So there will be 6 contained in this slide. The first one is the introduction. For the purpose statement, in Malaysia, there is a less efficient method such as RFID or manual counting being used, and this method often leads to inaccuracies and counting due to the issue of miscounting. Therefore, a better approach is needed to improve the counting accuracy, in which it will be the developed APC system. For the project ends, this project aims to develop an APC system for public transport using deep learning algorithm with vertically installed camera. Well, for the project objective, the first objective is to investigate the feasibility of using vertically installed camera and deep learning algorithm for an APC system in public transport vehicle. The second objective is to develop an APC system that have an AI model to accurately detect human object and count passengers entering and exiting public transport vehicle using vertically installed camera. While for the third objective is to evaluate the accuracy of the developed APC system. Then for the project scope, the first one is that the public bus will be the target public transport in performing the evaluation after develop the APC system. Then an AI camera that can provide real-time streaming option is preferable. The APC system will perform counting on passenger boarding and passenger alighting only. Lastly, the system will provide an interactive interface based on the registered counting information. The next part is literature review. So table 1 shows the studies of the related ABC technology. There's a lot of ABC being carried out from the researcher previously, such as the first one, as you can see, they use the deep learning direct counting, and then the second one done by the Hughes Xiong, they and they both use the combine of image processing, passenger detection, and also passenger tracking method to count the passenger. This slide shows the summary of the technology used. For the object detection, the Galan architecture in the YOLO V9 will be used. And then for the object tracking algorithm, the SOT will be used. For the media input, the Xiaomi AW200 auto camera will be used. And then the streaming will be used for the interface section. Well, lastly, the MongoDB will be used as the database. Move on to the next part, which is the methodology. There is the methodology follows the iterative model carried out by the Su Wang in their paper, and it starts with the requirement phase, which have been done already during the literature review, and then we will proceed to the sixth phase, which will be discussed soon. For the first phase is the object detection. The open source code for the implementation for the Galan C model is obtained in the YOLO V9 repository in the GitHub, thanks to the Wang C. And then the source code will be modified so it can be applied to our APC system. After having the object detection model, the second phase is object tracking phase. In the, as the same, the tracking algorithm is also obtained from the source open source in the GitHub. And then this source code will be implemented into our previously done object detection project. And with this, it makes our APC system to have a model called Galan sort in performing object detection and tracking. The phase 3 is counting. With these two preset lines called the boarding line and also the alighting line will be the indication of passenger boarding and alighting the bus. And then an effective counting algorithm will be implemented along with these lines to count the passenger. For the fourth phase, this is the media acquisition. For these two main sources will be fed into the APC system are recorded video and also the real-time streaming. In the phase 5, there is GUI and also visualization. Figure 2 and 3 shows the use case of the interface and also their description. As we can see, our interface will have the um, place for the user to select their media input, either by upload their recorded video or input the ITSP URL. And then after that, they'll be prompted with the interface to select the preset line. The user can either select the default one or they can customize the preset line themselves. After that, they can play the media and then they'll be able to view the real-time visualization along with the real-time media showing in the interface. After that, there's one more feature in this interface in which it allows the user to view the historical visualization. And then the second phase for the phase 5 is the database design. Figure 3 shows the example of database design of our APC system. As our APC system use MongoDB, so this figure follows the design of the MongoDB, in which we will be having a collection whenever we run our project, and then each collection will store the document. The document will be storing all the customer going in and out of the bumpy bus with the time of them being count. Lastly, for the evaluation phase, the evaluation is based on the performance metrics of precision and recalls. Precision will be review how good the ABC system counts the passenger, while the recalls will review how good the ABC system ignore the unrelated count, such as the bus driver. Move on to the implementation part. For the counting algorithm, there will be different scenario of potential. There will be a different scenario of potential counting, and it is summarized as follows. The first one is that the passenger intersect with the first preset line on the one frame, and then they stay inside the line, and in any other frames, they pass through the second line. And this, the model will detect it as one count. In the second scenario, the passenger moved too fast in such a way that it intersect both the preset lines. And then for the third scenario, the object is being detected during in the preset lines due to some maybe poor object detection, and it pop out in the middle of the preset lines. And after some given frame, it pass through and intersect with one of the preset line, and this will also be given a count. By having these three scenario implement into our source code, the APC will be able to count the passenger efficiently. For the media input acquisition, the recorded video will be stored in the temporary folder. This is because of the nature of the streambit file uploader widget. It only remembers the name of the file, but not the path. Therefore, the temporary folder is consistent in every Windows device, and putting the file inside this temporary folder, it will be recognized by our APC system easily. But for the real-time streaming, uh, RTSP URL is needed into our system by and the link can be generated using VLC media player. And then for the visualization, the data from MongoDB will be read by the system and then displayed interactively inside the interface as shown in Figure 4. The Figure 4 showing the visualization of one-day trip taken in the UTM C1 bus during 27th of June. In the evaluation phase, this site show the performance of APC system on real-time streaming. As you can see, the precision and the records are quite high. And the next slide is the performance of APC system on recorded video, and both of them are also showing a high accuracy. For the discussion, you can see that both input in form of uploaded video and real-time streaming have a high precision, with real-time achieving more than 85% and recorded video achieving more than 98%. A poor performance in real-time input when compared with the recorded video are due to the drop in frame per second. The frame per second during the real-time streaming on 27th of June stays in the average of 8, while the frame per second for the recorded video are always maintained as at 20. Another poor performance of real-time input is because of the memory allocation while the streaming is ongoing. This behavior is noticed in between the early trip and near late trip of every session. Such yeah. Lastly, both media inputs have a high record. This means the APC system is able to ignore the bus driver all the time. And this directly depends on the way the preset line is drawn. During the evaluation, the preset lines are drawn as far from the bus driver as possible. For the conclusion, the first objective is fulfilled by extensively investigate the feasibility of the camera and deep learning algorithm. For this, the AW200 outdoor camera with good FPS and high resolution is selected, and Galan C with its good balance on processing speed and detection accuracy is selected. For the second objective, it is fulfilled by having a Galan sort model. This model is capable in performing object detection and object tracking tasks efficiently during the real-time streaming. For the third objective, it is fulfilled by evaluating the accuracy of the developed APC system in both recorded video and real-time streaming. And the result is promising, where the performance of APC system on real-time streaming and recorded video are in more than 85% and 98% respectively. So that's all of my video. Thank you.